Hello everyone. In the last video, we talked about the Brent algorithm, and the Brent algorithm forms the basis for MATLAB built-in function f0 and fmin bnd. In this video, we will talk about how to use f0 and fmin bnd in MATLAB. The f0 function is designed to find the real root of a single equation. A simple representation of its syntax is as follows: f0, and then the first parameter is function, which is the name of the function being evaluated, and then the second parameter x0 is the initial guess. And you can have two guesses that bracket the root, and then the second parameter becomes a two-element vector, x0 and x1. x0 and x1 are guesses that bracket a sign change. If you don't have a sign change, it will return an error message. And when you use this syntax, you need to pay attention to when you have an initial guess x0, this initial guess should be reasonable, which means it should be reasonably close to the actual root. If it's far away from the root, then f0 may not be able to find the root. So it should be reasonable initial guess. Okay, and also when you have two guesses that bracket a sign change, and for some cases you may have, for example, this is the, for example, this one is x0 and this one is x1. So in between x0 and x1 does have a sign change because fx0 is positive and fx1 is negative. However, in between there are three different roots, right? If you use f0 to find the root, it will actually randomly return one of the three roots in between x0 and x1. So these are the things that you need to pay attention to. Okay, here is a simple example that solves for the root of a simple quadratic polynomial x squared minus 9. Clearly, two roots exist at -3 and +3. So the first one, use f0 and then at symbol x squared minus 9, and the initial guess is -4. If you have initial guess -4, the root, it will find the root that is close to this value, so it returns -3. And if your initial guess is +4, then the root will change to +3. It will always return a guess that is near the initial. It always return a root that is close to the initial guess. Okay, so you can have two initial guesses that bracket a sign change like 0, 4, and then it will return the root 3. If you don't have a sign change, you use -4 and 4. So then you will get an error message. Okay, so you need to pay attention to the syntax when you use f0. So there are three different ways to use it. The first one is you can define a function like find equal to at x squared minus 9, and then use f0, and so the root is equal to f0. So the first parameter is the name of the function find, and then the initial guess 4, right? So this is fine. Or you can directly use the at symbol in f0 without giving the function a name. So you can use at x squared minus 9 and then 4, right? So this also works. In some cases, if your function is defined in a separate function file, so for example, you have a file called fun.m, and inside this file, you have function y equal to fun x, and then y equal to x squared minus 9. And then in the main function, you want to use this function in f0, so you need to have root equal to f0. So here, you cannot write find directly. You need to follow a syntax at, and then x, and then find x, and then the second parameter is the initial guess. Okay, so pay attention to this syntax when you define the function in a separate file. Okay, so similarly, you can use fmin_bnd to find the minimum of a function. So the syntax is as shown here, where the x and f_val are the location and the value of the minimum. So here should be x_min is the location of the minimum, f_val is the value of the minimum, and the function, the first parameter of fmin_bnd is the name of the function being evaluated, and x1 and x2 are the bounds of the interval being searched. So note that the x1 is the second parameter, f2 is the third parameter. So it's unlike the f0, which use a two-element vector as one parameter. So the syntax is different from that of f0. Okay, so when you use fmin_bnd, you can have one more parameter called options. The options is equal to optim set display and iter. So if you use this, it will show you the details about how fmin_bnd finally located the minimum. It will show you the process. So I will give you an example about using this parameter options. So for example, you have a function x squared minus x. We want to find the minimum in the interval from 0 to 2. So if we use options, so first we write options like this, and then second we have xmin f_val equal to fmin_bnd and at x squared minus x 0 2 and options. Okay, if you do that, you will see the details about the process of how MATLAB finally located the minimum. Similarly, for f0, you can use the options, the same option here. You can include it as one parameter in f0. So the root will be f0 and then at, for example, the function is x squared minus 9. We want to find the root from 0 to 4. And then you have options. It will show you the details. So let me show you how it works in MATLAB. So first we have options equal to optim set, and it's display and iter. Then you can have xmin f_val equal to fmin_bnd at x squared minus x 0 to 2 options. Okay, so it will show you that finally, the x value corresponds to the minimum is 1/2, and the f value at the minimum is negative 0.25. But it will show you the details, like in the first iteration, what's the x value, y value, and in the second iteration, what's the value, x value, y value, and also which method it uses to search the minimum. And it uses golden, which is a golden section search, and then parabolic. Once the root is approached, it shifts to the faster open method, parabolic interpolation. And here you can see the details and why the optimization terminated. Okay, so this is the very useful parameter options. In the next video, I will talk about some examples of how to use F0 and Fmin BND to solve practical optimization problems.